Welcome back to our analytics. Now we have a uh, channel name, so we are now called the data nerds. Um, so thankfully, you'll all if you're following till now, you'll be called data nerds. So that's pretty cool. I have created here a data set. Today's topic will be about subsetting in R. Uh, I have created here a data set which has one, two, three, four, five normal rows. It is basically a survey data set where there are five managers, one, two, three, four, and five. And there are dates here with against whom the survey was taken for 5 particular days, and they're from US and the UK. Their genders are respectively so, ages are respectively so, although 99 is just outrageous. But these are the survey results for them. There are five questions that were asked, and then I have combined them into a data frame by using the data.frame function, which we talked about in the previous video. It had manager, date, country, gender, age, and Q1 through Q5 variables. If I want to create this first, and then I want to see how it looks like the structure of the leadership. It's a data frame, five observation of 10 variables. Okay, so now I want to select the variables last five columns, last 4 or 5 columns, all the Q columns I want to select. Then what I can basically do is I can give 6 through 10, and this will select me all of the five observations of the five variables. So leader LDR1 will the data frame will be a data frame that will have five different columns, Q1 through Q5. We can also similarly create an LDR2 which will have the values of Q1, Q2, Q3, Q4, and Q5. Right now, it's just a vector which which has these variables, because if you want to see that, we can see that using LDR2. And so right now it is a vector which has all of these variables. But we what we can do is we can pull this from the leadership, assign it to leaders underscore df1, and then it becomes LDR underscore df1 becomes all of these five variables, if you're able to visualize it. All right, moving to LDR3, what we did here was what you can do. There's a paste function in R. This paste function is basically, you can think of it, it is a string concatenation function where it can concatenate uh, the a, a static character with a now changing number. For example, if you want to create a B 1 through 100, then what you can do is come here, write B 1 through 100, and I don't want to give a separator, so I will not give a separator here. But right now, I just wanted to do Q1 through Q5. I just wanted to do create a variable for all of these. So I wrote paste Q 1 through 5, and then I don't want to give a separator. If I did this, LDR3 becomes the same thing as LDR2, and which can be seen by Q1, Q2, Q3, Q4, Q5. And finally, I can put this against leadership and pull the values in from leadership. So leader underscore df3 will become, so leader underscore df3 will become Q1 through Q5, or all five rows. I can also pull the first row itself by using just the one. If I just use the one in single square bracket, it will only give me the first column, but in a data frame format. However, if I had used a double square brackets and brought out one, then it would have given me the same row, same column, but in a vector format and not in a columnar format anymore. I could also have brought out LDR DF3Q by using the character name of the column, like by using the column name. Um, if I would have done that, it brings out the column and the like in a data frame format. But I can again do the same thing and put it in double square brackets, and it brings me a vector now. And if I put a dollar sign, I can also do this. Again, it will bring me a it will bring a vector sign for vector format for me. So that is something that you have to like be careful of. That dollar sign always brings out a columnar, because it's basically what it's doing is it's picking the data, it's selecting the data, and then it's kind of removing the structure from it and then giving you the result. We can then move to excluding observations, where I have done I've created a LDR variable called LDR vars3. It's basically storing all the names of leadership in Q3 Q4. Basically, it's picking Q3 Q4, then it's picking against names of leadership, and then it's checking how many columns have a name of Q3 and Q4. Once I did this, I can visualize that by LDR vars3. So if you see false, 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 true, true, and then false. What I could have done uh, here is also LDR vars3. So if you see this, it only brings me Q3 and Q4 data. It doesn't bring me anything else. So same thing has been done here. LDR Q3 Q4. So LDR DF4 becomes the same value as shown above, and LDR DF5. I have put an exclamation mark here. If you're able to see this, there's an exclamation mark here, which tells you that the values of the LDR leadership should be brought such that everything else is covered. So if I bring it LDR DF5 now, all columns are brought in except for Q3 and Q4. That's an important thing. Similarly, I could also have not brought ninth and 10th column by using a minus sign. That also becomes really important. LDR DF6. I can see that only data up till Q3 is being shown here, and Q4 and Q5 have been dropped. They're not there anymore. I could also have removed data by using LDR $Q3 is equal to $Q4 is equal to null, or I could simply have written, if I wanted only Q3 to be dropped, then I could have simply written this. And now if I want to see, leadership will never not have Q3 anymore. Let's just load leadership again so that it can be full. Selecting the observations. Now, above we have gone through the selecting of the variables portion. Now we'll be going through the selecting of the observations. If I pick new data leadership of 1 comma 3, it will give me a head of 3 rows, and it will give me the first three rows of the data. I can also use a function called which in R, which says it's basically, you can think of it same as if function, and it's basically saying it's basically telling R that I want data such that leadership of gender is equal to male, and leadership of age is more than 30. So I want all this more than 30 years old males. And if I want to see the new data now, there are only two people such that these they meet this condition. One is working in the US and one is working in the UK. I can also use a function called attach. This attaches the leadership data into the R library, and now I don't need to really call out leadership dollar anymore. I can directly use gender function and age function, sorry, age variable and gender variable in the filters. So now I can directly run this and see that the data matches what we had brought above. I can then detach, when I'm done with my work, I can detach the data, um, so as to ensure that our memory is not being utilized. I can also, in the date function, what I can do is I can tell R to read date in such a format that it's month followed by date followed by year, and then I can give a start date and an end date to R, and then I can give that give filter that the date should be greater than start date but lesser than end date. And now if I want to see, there's only one survey that happened on the 1st of May, which happened in the UK against a woman manager, manager number 5, and these were the survey results that they had gotten. This is kind of the same thing that is being repeated again. I can basically use a subset function also instead of the which function. Subset function, in the subset function, I don't really need to provide the data set outside. I don't need to do the leadership square bracket. I can subset the data, give the data frame here, and then add the condition. Um, and the columns that I need to be select. So subset is a function that takes a data frame, adds a condition to it, and we can select the columns that we need to supply. If I do this now, it will give me Q1 through Q4, all the columns that we've given here. And new data 3 is basically subset of leadership, this condition, gender equal to male and age is greater than 25. Oh, sorry. One thing that I missed here was this pipe is basically or in R. It can basically be saying that age is greater than 35 or age is less than 24. So that is why it is bringing me 2, 4, and 5, because age for 5 is 99, which is greater than 35, and 2 and 4 meet the condition of age is less than 24. If I subset this leadership to gender equal to male and age is greater than 25, and I select gender through Q4 columns, if I run this, it will give me new data. New data 3 will give me 1 and 4. Since these are the only two rows that meet this condition, that it gives me gender through Q4 all of the variables. I can pull a random sample in R as well. It is done by using a sample function. What it does is it brings sample of n once 1 to n row of leadership, number of rows in leadership. Number of rows in leadership is 5, so 1 through 5, it replace equal to false. So now if I give my sample, it brings me 1 through 5, replace equal to false, so it will not be replacing any rows, and I want a sample of 3 rows. If I would, what I can do is here is replace equal to true, and now what I can do also here is I can give this as 6, and I know that my like the leadership table doesn't have like 6 rows, it only has 5 rows, and so my sample will now repeat the rows. So 3, 3.1, 4, 3.2, and 1, 3.3. So 3.3, 3.2, and 3.1 are all repeats of 3. So that is why they are getting appended by 0.1, 0.2, and 0.3. They're basically telling that 0.1, 0.2, and 0.3 are repetitions. They are not the original row. This becomes important when you want to do some modeling in R, like machine learning in R. We'll come to it when we do machine learning, if we cover that at all. SQL in R. You can also run SQL in R. That this is completely something that I have learned today. I did not know that we could run SQL in R as well. So, if I run, for example, the library Titanic, which we had covered yesterday, and I load it and install that package is sqldf. Now, sqldf is the package that you need for running SQL in R. And I run this library sqldf. What I can basically do is I can write a SQL command saying select star from Titanic df where survived equal to 1 and passenger class equal to 1. And I want to get the row names as well. My Titanic df was not loaded. I'm sorry. Titanic train. Titanic df equal to Titanic train. And now if I run this, Titanic df2 will become. All of these records had such a data where they survived and they were in the first class. What I can also do is run a SQL command saying select of average fares in the average age and survived and passenger class from the Titanic DF, where passenger class is equal to 1 and group by the survived and the passenger class. If I run this, I am able to see that funnily enough that if you paid more fare and you were lesser in age, you had a better chance of surviving if you were in a passenger, like the first class passenger. If you were paying more, like pay more and survive kind of thing. It was something that was followed by Titanic. So yeah, so this is how we can run SQL in R. I think today we covered a lot of topics, and tomorrow we'll be covering joins, and then we'll be moving into the entire data analysis, like how vast R is. Like it's I need to cover it in bit by bit, and so that's why I need to cover joins tomorrow so that I can basically start talking about the analysis of portion of it. All right, thank you for joining today's video, and thank you for walking through it. If you did, it really means a lot. Hit the like button and the subscribe button if you like today's video. Thank you.